This is Mrs. Kraft, and I'm going to give you your notes for your introduction to speed. You should have a worksheet that looks something like this. We are going to start with this side, the side for the thought bubble. And first of all, we're going to start with constant speed. So if you look at the way the thought bubble is arranged, we have three different types of speed we're going to talk about: constant, instantaneous, and average. And then we have something else here with arrows, and we're going to indicate what that is a little bit later. So starting with constant speed is when speed stays constant or stays the same. This would be the same as using cruise control on the car. When you are walking, it's very hard to maintain a constant speed. You would have to really be thinking about making sure you take your same size step every 2 seconds or whatever the time frame may be. But constant just means that we're staying at the same speed. That could also mean that your speed is 0. So if you are just sitting there on the couch, then you have a constant speed of nothing, not moving. Next is instantaneous speed. Instantaneous speed is when it's in an instant. So if we were taking your walk home, at any given point, you might be going a little faster or slower. So at a very specific time, we would be able to calculate your speed at that moment. The last type of speed we're going to talk about is average speed, and this is actually the one that we are going to focus on in class. This is the one that involves math. But don't be freaking out because it's really simple. It's just a division problem. To solve for average speed, we have total distance divided by total time. This could look like this or this. Now the textbook and myself, we're going to use V. If you're confused about why speed would be V, I want you to think of average speed. So there's a V in average speed that helps me remember. So average speed equals distance divided by time, or I would allow you to write the S for speed equals distance over time. Now I said there was 2 arrows here. The arrows are there because they are both vectors. Velocity and acceleration are both vectors, which means from what we learned last week that a vector is a quantity with magnitude, which is size, and direction. So velocity is going to have a number and a direction. Acceleration, same thing. On your notes, please write vector, and that it's direction and speed. You must have both for it to be a vector. The direction is the magnitude here, or the size of the arrow. 2 examples would be 35 meters per second to the right, or 3 feet per minute to the north. Now, the 35 is going to be that speed, 35 meters per second. A speed always has to have a distance over a time. So I have a meters divided by seconds, or I have a foot divided by a minute. And then the direction here is right or north. Acceleration is also a vector, but this time it's a change in velocity. If you look back at that last bubble, we saw that velocity means direction and speed. So to change velocity, we only need to change one of those. It could be a change in direction or a change in speed. 3 ways that things accelerate are by speeding up, slowing down, and turning. Now, you might be used to the term accelerator in the car, and that would be like the gas pedal. But that's just for normal humans. We're science humans, so we know that acceleration is not just speeding up, it has to also include slowing down and turning. So your brake pedal is also an accelerator. It's just in the opposite direction. And then anytime you turn the wheel, that would also change the acceleration because it changes the direction. So now we should have this worksheet done. We're going to move on to the other side for calculating speed. First, I'm going to have you fill this one out. Average speed equals something over total time. Please look back at the thought bubble thing we just made. You should be able to fill this one out on your own. Okay, hopefully you did it on your own, but average speed is total distance over total time. So I'm going to show you one example of a distance unit, a time unit, and a speed unit, and then I'm going to expect you to do 2 more on your own, which I think you are totally capable of. So for distance, it could be any unit of measure. So I'm going to use feet. For time, it can be any measurement of time, and I'm using seconds here. So my speed unit would be distance divided by time, feet per second. And when we use that slash, like miles per hour, we're actually meaning it's a division sign. So feet divided by a second, or feet per second. Okay, I'm gonna wait for you to add 2 more distances, 2 more times, and 2 more speeds. I'm gonna have some dead air right now, but then once I start going, if you haven't finished, please pause the video and actually add 2 more examples. Okay, hopefully you are done, or you can pause. Now, for these 3, I went ahead and just gave you the answer here so that you can see how things are rearranged. But I want you to know that there is a math way to solve for different letters. And once you get to high school chemistry, that is basically your way to succeed. So if our normal equation is v equals d over t, then distance, right, we would move the t. To get the d by itself, we have to multiply both sides by t, and you end up with d equals t times v. To get t by itself, then, we would have to divide both sides by v, and we get t equals d divided by v. Once again, I'm using v for average speed, but if you wish to use the letter s, you may. Now, this nifty little triangle, I would recommend you write it down. It actually is a wonderful way for you to figure this out without using the math and without memorizing. As long as you learn this triangle, you'd be good. For example, if we're solving for speed, we put our finger over v. So go ahead and put your finger over the letter v. You should see that you have d over t. That's all that's left. So d over t. Now same thing. If you cover up the letter d, you end up with t next to v, which in math we know that if 2 letters are next to each other that they're multiplying. So we actually have d equals tv. And then to solve for time, we do the same thing. We cover up the letter t, and you end up with d over v, which must mean distance divided by average speed. So those are your 2 worksheets. Later on, we're going to cut them apart and we will glue them in, but not today. So go ahead and stop this video, and if you have any questions, please let me know. Thank you.